Hi guys, how's it going? This is edutech. In this video, I'm going to show you how you can solve this quadratic equation here. It says x squared minus x minus 20 equal to 0. Okay, I'm going to show you how you can determine the factors and also how you can factorize and then subsequently get your actual answers. Okay, so I'm just going to wipe up everything. I have a slide that has the first few problems. We're going to use that. So what you have here is you have x squared minus x minus 20 equal to 0. There's a chance that this is factorizable, but then you wouldn't actually know it just by inspection unless you know this particular problem. If you're interested in knowing how you can know whether this is factorizable or not, the b squared, which is called the determinant of b squared minus 4ac, it must be a square. So it must be a square, e.g. 100. If it's 100, then you know that this is factorizable. I'm saying factorizable in the sense of, can you put two brackets here and then actually find the factors and then solve this way? Okay, some of the questions you cannot do that. So here I'm just going to test it out with you. Okay, so remember these symbols b squared minus 4ac, they're actually coming from the general formula form. The general equation, the general quadratic equation, which says ax squared, then plus bx, then plus c, okay, so equal to 0, the general quadratic equation. Remember, in this case, a equal to, just by comparing the coefficients, a would be equal to 1, b would be equal to -1 here, and then c would be equal to -20, okay. This is not very important in this case, just because we actually have a case where it's factorizable. But then if you just want to, if you're confused, you don't know whether you should apply the quadratic formula or just straight on factorize, then this is a good exercise for you. So b squared, yeah, when I'm substituting, I always use my brackets, okay. It helps me keep my signs sane. It helps me keep my signs in a way that I cannot get them screwed up. So here it's -1 to the power 2, so it's obviously 1, and then here it's negative and negative on the 4 and then on the 20. So here I'm going to get positive what? Positive 80. Okay, when you add this, you actually get 81. 81 is a perfect square. Okay, so 81, it's a perfect square. So this is good. It means that this is factorizable. So if it's factorizable, how do you find the factors? So here you're supposed to determine what's called the product. The product for this case, for the case where the coefficient is 1 here, the product would be equal to AC, okay? So AC, for the case where this one is 1, it's simply C here, okay? So the product would be equal to -20. In other words, you take the coefficient for x squared and then you multiply by the last number here, which is a standalone number. You get your product. And then your sum would be the coefficient of x. So in this case, it's just -1. So the reason this is important is that these are the guidelines that can help you find the factors for which you can factorize the expression. Okay. So here, the way that I like to teach my students is you take the product, just ignore the signs for now. Okay. So I'm just going to take the product to be 20. So I can start with 20 multiplied by 1. I want to change it up, okay, until I have something that I can work with to get -1, okay, two numbers that I can work with to get -1. So I can actually go ahead and divide this 20 by 2, so I get 10. And then if I divide this one by 2, I can multiply this one by 2 as well. I get 2. And no, notice that I didn't actually change the product. The product is still the same. This is 20, this is 20. So I can keep on doing this exercise until I have a sum of -1. I have numbers that can give me that sum. So here I can divide this one by maybe 2 this time. Then if I divide this one by 2, I get 5. So I can multiply this one by 2. Okay, so you divide by one number, you're supposed to multiply the other number by the same number. So I get 4 here. Okay, so you don't write equal to 20. It's unnecessary. I was just writing to illustrate to you that we're not changing any math here. We're just changing the presentation. or the number combinations. Okay, so you know you have 5 and 4. These ones you can work with. So if you know your direct numbers very well, to get -1, it means that you'd have -5 plus 4. Okay, so it's like a tug of war. -5 is saying let's go to the left, and then 4 is saying let's go 4 steps to the right. So at the end of the day, the compromise would be -1. Okay, so this one would be the more dominant one, so it'd be negative. And you say bigger size number minus smaller size number, then you just get 1. So your numbers are actually this number here and then this number here. Okay, so this one will be positive, obviously. So here you can actually straight on write -5, then here plus 4, like this, equal to 0. And then once you're done with this, either of this bracket could be 0. Okay, so x minus 5 equal to 0, or x plus 4 equal to 0, like this. So x would be equal to 5, or x would be equal to -4, like this. Okay, so this is just about it. This is how you work it out. Okay, so again, you don't actually need to justify your factors using this thing here called the determinant. Okay, so you don't need to justify this using the determinant. I was just showing you when you're confused, when you don't know whether you're just supposed to use direct factorization or not, then you can actually apply this. Okay, you can also work out the same problem using quadratic formula, interestingly. So I think we should go ahead and do that. Okay, so x is equal to quadratic formula. Recall it from memory, you expect it to, but then I think they actually give you the equation as well. Okay, so it's b squared minus 4ac here, all over 2a. Okay, so the reason why we're saying that this one should be a perfect square is that if it's a perfect square, then the square root can dissolve without causing any decimals. Okay, so any unnecessary decimals that go on and on, we call them seds. Okay, so we avoid seds by having this part here, which is called the determinant, as a square. So anyway, you can do the substitution because we already identified that a is equal to 1 here, and then b is equal to -1, and then c is equal to -20. So you can actually go ahead and say negative, then b is equal to -1, so -1 plus or minus square root of b squared. I always use brackets, okay, so that I don't get my signs screwed up. Okay, c is equal to -20, like this, and then over 2, your a is equal to 1, like this. Okay, so you can actually just going to squeeze my math into the space here. So here I get this one will be positive, so it'd be x equal to 1, then plus or minus. Then here you'd be having 1. Okay, so here you'd be having 1, then plus this one would be 80. So it'd be getting 81, so square root of 81, like this, over what? Over 2. Okay, so my x would be equal to 1 plus square root of 81 would be 9, so over 2, or 1 minus square root of 9 of 81, which is 9 over 2. Okay, so I can actually get, at the end of the day, this one would be 10 over 2, which gives me 5, and this one would be -8 over 2, which gives me -4. Okay, so you can actually work out the same problem and get the same answers, okay, using quadratic formula. This has been fun for me. I hope it was fun for you as well. This is just about it. This is how you work it out. So this other part actually asks us to use, it doesn't ask us to use any factorization per se, but then it has these guideline. Okay, so it says correct to 2 decimal places. When they tell you this, it simply means you don't have exact roots as in the previous equation that we had. So you're actually supposed to use the quadratic formula, which is obviously advisable. But then where they want the exact value, you'd have to complete the square. Okay, or even use quadratic formula and then not actually punch the actual numbers. Okay, so we'll look at this, I'm sure, in some other problem sometime when they want the exact value for where the roots are not obvious. So here I'm going to work out the second problem. It's like 3x squared minus 2x minus 6 equal to 0 here. So now notice that this is analogous to our general formula for quadratic. Okay, so the general quadratic equation, is ax squared then plus bx then plus c. Okay, the reason this is important is that we want to know the value for a, b, and c. Okay, so the reason this is important is that a, b, and c are the numbers that actually define the quadratic formula. Okay, so if you know the value of a, then you can go ahead and substitute. So in this case, a is equal to coefficient of x squared, which is 3 for this case, and then b is equal to the coefficient of x, which is -2. Remember, a number owns the sign to its left hand side, so you're supposed to uproot the 2 with the negative as well. Then c is obviously -6, like this. So after doing this, you have to recall your quadratic formula. So quadratic formula, it says for this one here, for this equation here, it says x is equal to -b, then plus or minus square root of, then b squared minus 4ac. You're supposed to recall this from memory, but then you can also use the formula booklet, okay, or the formulas at the end of the paper. So you have this, and what we're going to do is to substitute now. You have x equal to negative. There is a negative which is there already. It's naturalized. Then you have to factor in the b part. So the b part actually has its own negative. The way that you avoid getting careless with your signs is that you just whenever you substitute, always use brackets, even in cases where it's obvious. Okay, it will help you get a hang of handling signs. Okay, so this is b's negative. This is b squared. So already b was -2, so that's why I wrote this. And then minus. Then there's a 4 which is naturalized. I have to write a it's 3. Then I have to write c it's -6, which is good for us. Okay. And then obviously the whole thing is over 2 multiplied by a, which is 3 here. Okay, so this is good. So here, what I get is negative and negative. I get 2. And what I'm trying to do by simplifying this, because you're supposed to ultimately use your calculator, but then if you're wise, you can actually just straight up punch this whole thing. It would give you the correct answer. But then what I like to do is to simplify it a little bit so that I don't get careless with my signs. Okay, so here I get 4, then plus. Here I get plus in the sense that negative and negative gives me a positive. So here I'm going to simplify it up to 12 multiplied by 6, like this. Okay, I don't need to simplify further. You can actually tell that 12 multiplied by 6, it's 72. If you want, you can go ahead and write that. It's still fine. But then I want to finish it up to this point, just because I know my substitution will be would be easy like that. Okay. So what I'll do is to take my calculator, and then whenever you have your calculator, let me actually delete everything that's there. Okay, so let me actually delete everything so that you know this is how you do it. So you take your calculator, depending on the module, obviously. You're supposed to use a scientific calculator, so I'm guessing everyone has this part where they can use the fraction. Okay, so here I'm going to write 2. Then here it says plus or minus on this part. So what we are going to do is to actually do the plus part first. So it'd be 2, then plus, then square root. So square root, it's this part here. And then we have 4. So I get 1.79. Okay, it says to 2 decimal places. So I get 1.79. So I'm going to write here, I'm going to say x is equal to 1.79, but this is a quadratic, so there's also a second value for x that we have to define. Okay, so here you probably know this, but you're not supposed to rewrite the whole thing. What you can do is to go on the positive side, then you put negative there, so you get negative 1.12. Okay, so you get negative 1.12. So I'm going to write or negative 1.12 like this. Okay, so this is my answer. So these ones would be your actual answers. Okay, in later video I will be telling you how you can actually verify some of these answers. Okay, so you can actually verify and know whether you're doing the correct thing or not. But then essentially for the second part, this is how you go about it. Just use your quadratic formula and then substitute just punch it on your calculator when you feel comfortable, and then you should be fine. Okay, and remember, you're supposed to do for 2 answers just because it's a quadratic equation. Okay, so I'm going to wipe off this, and then we're going to go straight on to the third equation. So third equation, it's actually an inequality. So it says x minus 1. So let me write my x in a better way. So x minus 1 squared, then greater than 9. So some of you may be tempted to expand this, which is quite fine. You can do that, or you can just recognize that if you take the 9 to the side, then it becomes difference of 2 squares. Okay, in what sense? 9 is simply 3 squared. Okay, so I can here now I now have this square here, and I now have this square here. They're separated by a difference. So this is really good for me. It means that my factorization can be really quick. Okay, so here I just need 2 brackets. So I'm going to put my 2 brackets here. And then obviously it's greater than 0. And then in the first bracket, I'm going to put my first number, so which is x minus 1. Here, the root for the first square. Okay, so this is what I'm writing. So the root for the first square I'm writing on one side, and then also on one side. And then the second square here, the square root would be 3. So I'm supposed to write plus 3 and then minus 3. This is based on the general formula for factorizing difference of 2 squares. Okay, so whenever you have x squared minus y squared, you'd get x here, then you'd put x here, and then you say plus y, then minus y. In other words, the square root of the first square comes first, okay, in each bracket, and then you add and you subtract alternatively for the second square. So here, if you actually notice, we have x minus 1 plus 3, so you just get x plus 2. And then here you have x minus 1 minus 3, then you get x minus 4. And this is greater than 0. So your roots, you're supposed to be clear about what your roots are. So your roots would be x equal to negative 2 here, or x equal to 4, okay? So this ones would be your roots if you were solving an actual equation, okay? But then this is an inequality. I'll show you where the roots would be proposed, okay? So here you'd be just writing your general equation for, you can say f of x is still fine, you can say y, it's still fine, okay? So our graph would it be smiling or would it be frowning? I think our graph would be smiling. Why? Because the coefficient of x squared for this case would be positive, okay? If you expand this, you actually get x squared, then the rest of the equation, okay? So if x squared, the coefficient is positive, then it means that our graph would be smiling. So I'm going to write this. It's smiling as opposed to frowning. Frowning would be this, okay? So I think that's how you'd basically present someone who's frowning. So here, our graph, we say that it will be smiling, or it would have a minimum, to be more technical, okay? So after doing this, now you have your value, so you can actually put this is negative 2 and this is 4 here, okay? These are the roots that you're talking about, that we were figuring out here. So now you want the regions where this expression is greater than 0. So obviously it'd be these regions here, okay? So in other words, what's greater than 0 here are the y values. So if they say they want the y value is greater than 0, so you have to shed on the part of this, and then whatever area that you shed, it has to be between the x-axis and the graph, okay? So here, if they had said less than 0, then we would have done the shading on this part here, okay? But then they didn't say that, so we are stuck with this. And then the way that you present your answer would be to say x is obviously less than negative 2 here, okay? And then you say union. Union is just a way that we unite two kind of contradictory results. Then they're not really contradictory, they're just separate, okay? So you can unite them. So x is greater than 4, okay? So this would be your ultimate equation. So this is how you go about it. Remember, you can avoid you can skip some steps by just applying difference of 2 squares instead of expanding this whole thing, okay? So you apply difference of two squares. After you apply difference of two squares, then you can get to a place where you have you can determine the roots for the equation. If it were an equation, you use these roots on your graph here, so that you can ascertain the inequalities, okay? So remember, the area that you shared is supposed to be bound by the x-axis and the graph, okay? So depending on what you're told. So this has been really some fun exercise. I hope you understood it very well. I'm going to skip over to the last part, okay? The last part, it reads 2, then square root of x plus 6, then plus. This one is supposed to read plus, okay? When you're watching these papers, sometimes, you know, there are some mistakes that happen. But then this one was supposed to read plus 2 equal to x. So you're supposed to be able to work out this one, okay? So the way that you work it out is you say 2 square root of x plus 6. Then remember that this is a whole train, okay? And then this 2 is separate from the square root. It's equal to x. So what I'm going to do is I can kick this to the side. So I can kick this one to the side, such that the stuff with the square root is just left on its own, okay? This helps for clearing the square root. So it get x minus 2 like this, okay? So the way that we clear the square root is to actually square both sides. You can divide this one by 2 first, but then you're complicating it, okay? Because you're creating unnecessary fractions. You don't want that. What you just want is to clear the square root. So you can do that as long as you can apply, and you can know that you're supposed to apply the square on the whole train, okay? So even this 2 is affected as well. So this 2 would read 4, and then this one you'd read, you'd have x plus 6, just like this, okay? So here you can actually go ahead and expand so that we can minimize some of the steps. So here, for squares, it's supposed to be x squared. Then here, obviously, minus 2, then you get negative 4x. Then plus 4, you're supposed to be able to factorize squares by, to expand. You're supposed to be able to expand squares by just recalling the formula, okay? You can look it up in your work as well. It's not very hard, okay? Rather than expanding the brackets and then taking the expansion, which would be time consuming, you can just straight ahead go and expand, okay? So here what you get 4x plus 24 equal to x squared minus 4x plus 4. Then we put everything on one side. Remember, some of these steps, they don't really have marks with them. So here I'm going to write x squared. I'm putting everything to the side. So here it's negative 4x, so negative 4x again. Then I'm writing negative 8x here. Then this is 4, so 4 minus 24. So 4 minus 24, you get negative 20. So I'm going to write negative 20 equal to 0. So this is what we have to work out. You can actually pause the video. Since we did this question here, you should be able to do this one as well, okay? So you can actually pause the video and then try to do it on your own. In this case, the sum would be equal to negative 8. The product would be equal to, so I'm just going to write product is in multiply, it's equal to negative 20, okay? So again, I take 20 multiplied by 1, which would be the first one, and then obviously I can divide this one by 2, so I get 10. Then multiply by 2 here. I can use this 10 and 2 to get negative 8. How would I go about it? I would say negative 10 plus 2. And notice that negative 10 plus 2 actually gives us negative 8. And then when you multiply them, you get negative 20. So this is really reassuring for us, okay? So here I'm going to write x, and then I'm going to write x, and then I'm going to write equal to 0. So here it's negative 10 on one side, and then it's plus 2 on the other side. So x is equal to 10 or negative 2. This, okay? So this one would be your solution. So I think we still have some questions left. So the next part, the 1.2, it says solve the simultaneous equation for x and for y, okay? So you have this one should be a quick one. So you have 4x plus y. I want to use a method that's kind of unorthodox, okay, to use just because it's more convenient for this part, okay? So I can actually use elimination here. You still remember the method of elimination? Yeah, the basic elimination. That's what I'm going to use. I'm going to use it in the sense that if you notice 4x and 4x here, they can actually just cancel if I'm to subtract them. And then I put these big square brackets. These big square brackets, they remind me that I'm supposed to subtract everything that's in that train, okay? So when you subtract this one, you just get 0. So I'm not going to write anything there. But then here, I get y minus y squared. Then here I get negative 4, I think. I actually get negative 6. So 2 minus 8, I get negative 6 like this. So this must be a quadratic equation. I want to change it into 1. Okay, so here it'd be y squared, then minus y. So I'm putting everything on the side. So here it will be minus 6 equal to 0. So I'm just supposed to perform my factorization. This must be familiar with you, okay? So if you're working out so many problems every time, then you probably can predict that this is factorizable, okay? Where it's not factorizable, you have to use the quadratic formula. And there's also another way to actually tell whether something is factorizable. You say b squared minus 4ac, and then if b squared minus 4ac, let me remove the, I don't know why I put the square root there. If b squared minus 4ac for the equation, so in this case, this equation, if this is a perfect square, it means that our equation is factorizable. Okay, so you can actually go ahead and try it. So 1 squared minus 4, then our a is 1, and then our c is negative 6. Here you get 1, then you get plus 24. Here you get 25, okay? So 25 is a perfect square. The perfect square root is 5, okay? So we know that this is factorizable. And anyway, your product, remember the product something, I'm just illustrating for you here, but you don't need to write all this, okay? You're actually expected to know some of these concepts and then just use them as if you're using a calculator. So the sum, it's equal to negative 1. So you're dealing with 6 or 6 by 1. At first, I can't use 6 by 1 to get negative 1. So I'm going to divide this one maybe by 2. I get 3 here. Then I multiply this other one by 2. I get 2, okay? So 3 and 2, I can use them to get negative 1. How do I do that? I say negative 3 plus 1 plus 2, okay? I say negative 3 plus 2. So I'm going to factorize using those roots. So I get negative 3, then here plus 2. And then I get y minus 3 equal to 0, or y plus 2 equal to 0. So at the end of the day, y is equal to 3 or negative 2, okay? So this is only half the part, okay? You're supposed to get the values of x as well. That's the thing about simultaneous equations, okay? We're supposed to do for both. So you can take any one here, the easier one, okay? Since this first one doesn't have any quadratics in it, okay? It doesn't have any squared in it. So I'm just going to take that one. Equal to 2, okay? I'm going to make x the subject of the formula. You can do it in many steps, but then it's not really necessary. It's just a stage that we have to go through, okay? So here x is equal to this. And then now you say when y, not x, when y is equal to 3, then x is equal to what? Here we get 2, then minus 3 over 4, which is equal to minus 1/4, like this, okay? So this is good. And then you can also do the same thing for the other part. Well, what I'm going to do is to just use some space here, okay? I can actually take the space here, it should be fine. So the way that you do it is you'd say we're working with this, okay? So we're working with this. Now you'd say when y is equal to negative 2, okay? Y is equal to negative 2. You get x equal to 2 minus 2, then over 4, and you get x equal to 1 like this, okay? So therefore, your solutions would be, I'm going to write in coordinate form. So here when x is equal to 1, y is equal to negative 2, or when x is equal to negative 1/4, y is equal to 3, like this, okay? So this one would be your solution. If you want, you can say x, y equal to, then you say this, then all this, okay? That's essentially how you go about solving this equation. I hope you're happy. We'll do it obviously in another separate video if you didn't understand it very well. But then I hope you're really happy with this method. Very quick, and then you'll be able to compute your values for x and for y. Whenever you have a quadratic expression, then you can actually get a pair of values. Whenever you have a linear expression for, let's say, simultaneous equations, then you just get, just one value, one coordinate. So you'll be having one x and one y. Okay. So let's finish up with the last question. It says if it's given that 2 to the power x, so it says 2 to the power x multiplied by 3 to the power y equal to 24 to the power 6. Then find the numerical value for x minus y. So you can actually solve this by just matching the left-hand side. So the left-hand side it's saying 2 to the power x multiplied by 3 to the power y. You can also form the same, and you can do this by you can get a clue about doing this from the base here. So from this number here, which is 24. 24, it can be expressed in terms of 2s and 3s. Okay, so 2 and 3, those are the only prime number factors in 24. Okay, so we can actually use that. So I'm going to substitute 24 is equal to what? You can do a T diagram if you want, if you're not really sure. So you can say 24 here, then you get 2 into 24, then you get 12, then 2 into 12, then you get 6, then 2 into 6, then you get 3, then 3 into 3, then you get 1. Okay, so 24 is actually equal to 2 by 2 by 2, so this is 2 cubed, then multiply by 3. Okay, already you have the 6 here. Okay, so I'm going to replace it, and then in the next step, obviously you're going to remove this overarching power here. So the way that you move it according to the laws of indices, you remember a to the power x to the power y is equal to a to the power xy. Okay, so we're going to multiply the powers. So this one would be 3 multiplied by 6, then you get 18 here. This one would be just 3 to the power 6. Okay, so at the end of the day, you'd say by inspection or by comparing. So I'm going to write it's supposed to write by comparing the powers of x and y. We can deduce the following. Okay, so you can deduce that x equal to 18 and y equal to 6. Okay, so after doing this, now you can go ahead and get your numerical value for x minus y, right? So you can say therefore here it's a better way to go about it. Therefore your x is equal to 18, your y is equal to 6. So 18 minus 6, you get what? You get 12. So that's just about it for the first question. Okay, Matric 2021 June. This is how you are supposed to go about it. If you have any questions or you have any suggestions of the papers that we're supposed to cover, it'd be great as well. Love that. Okay, so thanks so much for watching. This has been Yuba. I'll catch you in the next video where we're going to do question 2 for Matric. Okay, so cheers. Yuba out.